Do you understand?
Yes,
Mass
sir.
is responsible for gravitational attraction between matter particles, whereas electric charge is responsible for electrostatic attraction and repulsion between matter particles. That's the only difference, and numerical values are different. We'll just see in a while all the mathematics behind it. Okay.
Yes, sir.
So mass goes to gravity and charge goes to, or vice versa, electrostatic force. I should write this even better. Gravitational force and versus electrostatic force.
Yes, sir. You can continue.
Okay. Next, we're gonna talk about properties of charge. Charge is of two types: positive and negative. Like charges repel and unlike charges attract. Did you follow that? You know this, right?
Yes,
This
sir.
is very easy stuff. Okay. Fairly simple stuff, this one. Now, one second.
Yes, you can continue.
Yeah. Third property is charge is conserved. What's the meaning of charge is conserved? It means that charge can neither be created nor destroyed. The amount of charge in the universe remains constant, which is not true. What you'll understand later, but yeah, for now you can just think that we cannot create or destroy charges, which includes electrons and protons, right?
Yes, so we're not considering emission from stars or anything.
I don't know how far you think, but Batao, explain about it to me, then I'll talk about it.
Like maybe
And
when
yeah, I
stars
mean,
die,
star
they release.
not just when they die. We are. I mean, you could have thought of this way that nuclear reactions are happening in the star at every second. Even on Earth, nuclear reactions are happening. There are nuclear reactors. And in general, if you just comb your hair, lot of charge. Oh, but we're talking about destruction of charge. Yeah. That's actually only happening in the Large Hadron Colliders of the world. I mean, not just Large Hadron Collider, but rather in general, just any particle accelerator. You can have destruction of charge. You can, if you create antimatter and matter, electron and positron, and they collide, then charge is well and truly destroyed. That's a rare happening actually. And I don't know about stars dying. I mean, what happens in a supernova? I'm sure it would go to that level where matter and antimatter will collide. I'm sure that is the, as you said correctly, I hope, the force responsible. Because nuclear force, the nuclear bomb, that is just fusion. That is not necessarily creating an antiparticle and striking it with its corresponding particle and destroying charge. The destruction of charge, you can destroy mass using nuclear reaction in a decently large quantity, but to destroy charge, you will have to do matter antimatter reaction, which is a little bit extreme.
So
So
like
yeah,
black hole doesn't have charge, right?
I mean, black hole, inside black hole nobody knows what is there, so you can't say. time stops at Time stops inside a black hole. It is all weird. I mean, nobody can guess. It's the singularity. After that, there is 100% possibility of anything, statistically speaking, because nobody knows after that what happens. Just like after death, what happens, everybody guesses. Same thing. Sorry to make it go that way, but that's actually true. Philosophy and that thing same. So nobody knows after the black hole what is there inside it because of basically lack of data. You never got any data from it, even in form of light. You could not even measure radiation from a black hole because it doesn't even let light escape. So it's a whole different world. Maybe it's the portal to another world, which is actually true. I
Like wasn't
mean,
there recent news about light from behind black hole or something?
not behind, black holes emit light like this. So if you think about it, it's something like this. This is a black hole which doesn't emit any light. And then the red I'm just using the blue to show light. It's actually white light, but light is emitted something like this, like a magnetic field or something. And then it's like a tornado or something that I saw on Discovery Channel when I was younger, maybe your age or younger than that. So that's how, and something like this around it. Yeah, that's how a black hole looks if it emits light. All this light is actually traveling from the edges to the center, much like in a solenoid. So nobody knows what happens there, man. Don't even try to judge. ठीक है, मतलब don't even try to think what happens inside a black hole, because Statistically speaking, everything is possible 100%. So that's the main thing.
Yes, sir.
I hope you got it. So black hole is more like a wormhole. You can think of it that way. Like they say that if you go into a wormhole, you enter into a new universe. So that is very much true. You could think of a black hole as being a wormhole. So, so now what I'll do is I'll move to the next part. Okay, let's move forward. Next, we're gonna talk about the next property. Charge is quantized, the most important property. Quantized means, like you said, it is made up of a collection of electrons. That's what it means. That the smallest entity is there, it is indivisible. Beyond that, we cannot divide charge. So that means quantized. It has small, small. In short, charge Q can be written as NE, where N is an integer. That's the shortest statement I can make about quantization. That's all I make. You have to understand yourself how it works.
Yes, sir. Continue.
So, do you understand the meaning of quantization of charge? What is the smallest unit of charge? What is this E?
Like 1.6, like the charge on electron. 1.6 10 to the
Yeah,
minus
how?
19.
Okay, you know that. Great, great. So we'll just directly jump to Coulomb's law now without wasting any more time on it because you are aware of these things. So what to do? So we'll next move to. We are going to skip charging by induction and stuff like that. We'll do it in the end. It's not that important. That you'll do in questions itself. You'll see. No need to study it. But you do need to study the Coulomb's law. I'm sure you know about it. F equal to K Q1 Q2 by R square, where K is equal to 1 by 4 pi epsilon naught is equal to 9 into 10 to the power 9, and epsilon naught is equal to 8.85 into 10 to the power minus 12, all in SI units. Are we clear?
Yeah, continue, sir.
Okay. So let's do a question. I want to place a charge somewhere in between two charges which are separated by a distance of 10 centimeters. Let's make it a meter. I want the force on the charge to be zero. Where should I place it? Now you continue. Ideally, you should get the answer in 2 minutes. Already, matlab, half a minute has passed. I'm counting down from 90. You can tell me the answer by then. I'll do a better one than that. Let's have a countdown timer for 60 seconds. I mean, yeah, 59. Okay. Okay, you can stop now. Now I'll set a timer of 2 minutes for myself and I'll try to solve it within the time frame. So both of them will repel the charge or attract the charge, so they will be opposite to each other. There will be two forces, K into 10 into Q by x square, if I call this x, and that will be equal to the other force, K into 5 into Q by 100 minus x square. So K and K will cancel, Q and Q will cancel. I'll have 2 here. That means 200 minus, sorry, 100 minus x whole square. So 2 into 100 minus x whole square is equal to x square. That means 20,000 plus 2x square minus 200x is equal to x square. So x square minus plus minus 200x plus 20,000 is equal to 0 is a quadratic. I'm not sure how this one will work. Let's try to use the discriminant method. 200 plus minus b square, which is 40,000, minus 4ac, which is 80,000. So that's not a correct equation. So I'll try again. 2 into 100 minus x whole square is equal to x square. Yeah.
So we can square root on both sides.
It would have been better if you could have caught my mistake there, but you weren't paying attention. Thank you. Sorry about that. 1, 2, 3, 4 minus 80,000. Okay, time's up. I lose, but I'm gonna carry on. By 2a is equal to 200 plus minus. I'll just take these out first, and then I'll take out what 2 root 2. Okay, so that's 200 root 2 outside. 200 root 2, and inside we have root 2 minus 1. Or you can just say, yeah, this is only what? No. Something is wrong. Once again. Yes. Plus minus. Yeah. So you just take this out. 1, 2, 3, 4. 100 out. 16 minus 8 is Forget about this. There's 100 outside here. And 16 minus 8 is 8. 8 root is 2 root 2. So that's 200 root 2 by 2. So one is negative, other is positive. Let's take the positive one, not the negative one. It's not acceptable to have negative distance. So it will become root 2 plus 1 into 200 by 2. So that will be 100 into 2.41, which will be 241 centimeters. Okay, not the ideal answer because I had only 100 centimeter between the two. But you get the drift. There is a whole, process. Okay, here also it should have been 4. That also it didn't tell. Very bad. So, okay, b square minus 4ac. Yeah. So this is 200. So 400 plus minus 200 root 2. Ye, so we can go negative also on this one. Or is what's this man? Or yeah, this is no brainer. I'm just taking a lot of time for some reason. 400 plus minus twice of 1.41 is 2.82. So that's minus 282 by 2. That is 118 by 2, which is 59 meters. So x is 50, sorry, centimeters. So there is a 59-41 split here.
Yes, sir. I had taken distance between that point and 5 microcoulomb as x, and I got 41.
Wonderful.
So it can only be placed between the
No,
two charges.
even on the right hand side of the smaller charge, if you look at it this way, there is another point. If we think intuitively, we'll get the answer, which is a distance of 241 from the left one. And not on the left side, it has to be on the right side. That's what we have to
Yes, sir.
judge because there is a smaller charge. No, but both repel. No, that's a bullshit answer. Both are repelling or both are attracting. Then also it's wrong. Yeah, it won't be in equilibrium unless it is in the middle of the two. So that other answer is unacceptable. For some reason, it's coming. I don't know what it is. Some jadoo tona, you know, some complex number or something like that.
Yes, sir. You can continue.
Okay. So next is Okay. Next, I'm gonna ask you another question, which involves two-dimensional thinking. There are 3-point charges on the sides of an equilateral triangle. All three are positively charged, plus 10 microcoulomb, plus 10 microcoulomb, plus 10 microcoulomb, 10 centimeter, 10 centimeter, 10 centimeter. You need to tell me what is the electrostatic force on any one electric charge. Simple question with a simple answer.
So I got it as 90.
Okay, let's check that out. Moving on to testing value 9 into 10 to the power 9 into 10 to the power minus 10 by zero point 0.1 square is equal to zero point 0.9 by 0.01, 90 Newton. But that's not the answer because you forgot to apply vectors. 90.
It's a 90 root 3.
Now you will talk. Before that, This is the force I'm getting. So I want to find the magnitude. Can you calculate this for me? This one.
So like I don't understand why it's 135 and 78.5. Like from where we're getting that.
Sine theta, cos theta. This is 90, this is 90. Break it down to plus 90 cos 60. This one becomes 90 sine 60. This 90 goes away. Or you can do another way, a square plus b square plus 2ab cos theta. 90 square plus 90 square plus 2 into 90 square cos 60. Cos 60 is what, half only, right? Yeah, so you were right. 90 root. I'm so stupid, you know. Are you aware of that? How stupid I am? Can you tell me more about it? Sorry, I'm just kidding. We wasted a lot of time. I'll give you extra time, don't worry. So I'm free today. We'll take 10 more minutes to do one more question.
Yes, sir.
Yeah, it's no hurry and no worry here. So example 3. We can go 2 hours also if you want. I don't mind that. Yesterday we didn't have a class. Today we can go longer if you want. You can take a break after 1 hour. 5 minutes or 10 minutes.
Yes, sir.
Sure. Third example, after which you can take a break or stop the class as you wish, sir. This is your system, and each charge is 2 microcoulomb, 4 microcoulomb, 2 microcoulomb, 4 microcoulomb, -1 microcoulomb, 10 centimeter, 10 centimeter. Now find force on each charge. You may start.
Which were made and on whose stability we fundamentally depend. Curious, touched her, wondering why nature is the way it is, where the cosmos came from, and whether it was always there. If time will one day go backward, or whether there are ultimate limits to what humans can know. What is the smallest piece of matter? Why we remember the past and look at the future? And why there is a universe. बचना है दिल आज है कोई
Yeah, so how far are we?
So like I'm still calculating.
Okay, carry on. Yeah, so let's discuss now. Let's see how far we have gotten.
कोविड-19 को बढ़ने से रोकने के लिए देश का सहयोग करें। थोड़े दिनों के लिए केवल बहुत जरूरी होने पर ही घर से बाहर जाएं और भीड़-भाड़ से बचें। 3 बातें याद रखें। मास्क पहनकर रखें, हाथों को अच्छी तरह से नियमित तौर पर धोएं और दूसरों से दूर रहने की दूरी बनाकर रखें। और हाँ, अपनी बारी आने पर वैक्सीन लें। अधिक जानकारी के लिए 1075 पर कॉल करें या www.mohfw.gov.in पर जाएं।
Hello. Good morning, sir. कल ही क्लास थी क्या? मुझे लगा आज नहीं, पहले सर पेमेंट होगी तभी तो क्लास शुरू होगी। हाँ जी। अरे नहीं सर, डेमो के बाद तो फर्स्ट पेमेंट करनी पड़ती है 4000 रुपीज एंड देन यू हैव 4 क्लासेस। सॉरी, जो भी है 8 क्लास ऐसा बता रहे थे ना आप। चार चार क्लास हफ्ते में, तो 8 क्लास हो गई। तो अब आपकी 8 क्लास शुरू होगी पेमेंट के बाद। पढ़ा सकता हूँ बट सर वही बात है, मतलब आपको भी क्या जरूरत है रोकने की पेमेंट को। तो आप डिस्पर्स कर दो और मैं शाम को शुरू कर देता हूँ। आप जैसे ही मेरे को 4000 रिसीव होंगे उसी दिन मैं शुरू कर दूँ। देख लो। ओके सर। People want to take a demo, then take more classes with making payment. Can you imagine this nonsense that they do? You are not like that. Your mom is very nice about it. You know? Are you listening? I'm praising
Yes, sir.
you and your family. She's very nice. So she will help you. But some people are like, yeah, let's do 1 or 2 more classes. I'm like, no, thank you. If they want to start, they'll start. I mean, if they don't want to start, they'll not start. That's what. Some people like me, some people don't like me. That's all. That's all about. But if enough people like me, then I'm a rich man. So I try to be as likable as possible. And I mean, it's very hard to like someone who takes money from you. But unless you are enjoying the service, I mean, I pay a lot of people and lot of small services like Microsoft storage and Google Drive storage and Dropbox plan and Adobe Premiere Pro for making videos and all that I'm trying to do. So small and Zomato, Ola, Uber. No, so I'm also making so many payments. So why are they so worried? Even Zoom, I'm paying 2500 rupees every month. Urban Pro is charging around 6000 every month. So what will you do? How do you think I got your number? First of all, I paid money. You understand what I'm trying to say to the uncle, but he doesn't understand.
Yes, sir.
Yeah, I mean, I anyway, let it be. They don't understand the business model. He negotiated me down to so low a rate, and still, Jai Ho, Uncle Ji. Uncle Ji is great. I have to now come down to the local Delhi rates now because I'm staying in Delhi. That's why. That is pathetic, actually. Anyway, let's not talk business here. This is not a business class. This is economy class. So Have you had breakfast?
Yes, sir.
Okay. So I'm really waiting for you to just answer this question. You can ignore whatever I say if I say anything. So just waiting for your answer. You can mute actually if you want. Or I'll mute myself. That's even better.
Sir, I sent the answer in WhatsApp.
I'm checking. So let's see. F1 for A equals F on C. F1 A equals F on C equals this much. F1 B equals F1 C. Okay. F1 A is 0 because of symmetry. Okay, so we'll take a 5-minute break here and continue at 9:15. We'll go all the way to 10 o'clock. Okay.
Yes, sir.
So you can come back online at 9:15.
So
Sorry, I think I got lost a little in making my tea. So we'll continue now.
yes, sir.
Okay, so this is Coulomb's law. More or less, we have understood it. Now more discussion is required. Let's go to electric field. What is electric field? What does it look like? So a positive charge is capable of throwing out lines of electric field called electric field lines or electric lines of forces. So these are electric field lines or lines of forces. For a negative charge, however, the field lines go in instead of going out. So that's what you have. If you have two positive charges, then the field lines will be repelled by each other. Same thing is true for two negative charges. In this case also, the field lines will repel, but the only thing is that these are inward facing field lines. Wow, magic. Call it magic. Call it too. I believe in magic. You should do. It's called artificial intelligence. Okay, let's continue. It's called computer science. Magic by most standards. So is physics. Electric field. Yeah, these are the lines of forces. Formula for electric field. For a point charge, E equals KQ by R square. Point charges in field. Point charge in a field. F is equal to Q into E. So I have a question for you. Yeah, do it.
magic.
So let's continue. Wait.
So send the picture in WhatsApp.
Yeah, so I saw your solution. I just want to know how you found the vector value basically. So if I draw this triangle again,
So like I didn't get any angle, so I didn't do that.
that's the biggest part, right? The best one. So this is 4, 3, and 5. 1 microcoulomb, 1 microcoulomb, 1 microcoulomb. So I know that this one has a force of, let's just call it F1, and a force of F2 on it. The angle is the real part. This is theta. This is also theta. So now you have to apply solutions of triangles, my friend. Are you aware of any identities, the sine rule or the cos rule? No?
No, sir.
Wonderful. So we will try to do it. I mean, it's not very apparent in the diagram, but I tried to make this perpendicular just for your, but yeah, it cannot be perpendicular unless it follows the Pythagoras theorem, which is perfectly does. 9 plus 16 is 25. So you never, I mean, you could have got this very easily. So this kind of a triangle has 37 degrees here and 53 degrees here. So you could have found cos 53. F equal to F1 square plus F2 square plus cos 52 F1 F2 cos 53. And cos 53 is nothing but the simplest of values, 3 by 5. Sine 53 is how much? 4 by 5. And the reverse is true. Cos 37 is equal to 4 by 5, whereas sine 37 is 3 by 5. So we are interested in this value currently. You can take a look at this, apply this here. Tell me the answer, my friend. Down, look up to the sky. Next thing I'm gone. Fly on down, down. Look up to the sky. Next thing I'm gone. Fly on. So, did you get the value? I'm waiting. What the hell? It's Yeah. So what's the answer?
I still haven't found it.
Let's wait some more time. I'll wait for you to answer now. Oh, fly on. Fly on. I'll come next to you. Fly on. Nope. fly on. Maybe one day I'll fly next to you. Fly on. Fly on. हेलो अरे भैया बड़ी जल्दी आ गया आ जाओ ऊपर आ जाओ ये 6 नंबर लिखा है ना जो राइट में जो है सीढ़ियों वाला उसमें आ जाओ फर्स्ट फ्लोर हाँ L6 फर्स्ट फ्लोर अरे खींचेगा तो खुल जाएगा ना गेट Still no answer. Very bad, my friend. Or did I miss your answer by any chance?
आके आसमान में दहाड़ दो
आरंभ है प्रचंड खोल मस्तकों के
की हवस नहीं किसी पे कोई वश नहीं क्या जिंदगी है ठोकरों पे मार दो मौत अंत है नहीं तो मौत से भी क्यों डरे ये आके आसमान में दहाड़ दो
आरंभ है प्रचंड खोल मस्तकों के झुंड आज जंग की घड़ी की तुम गुहार दो आन बान शान या के प्राण का हो दान आज एक धनुष के बाण पे उतार दो आरंभ है प्रचंड Sairam, you're taking too long. Acha, you got it as 12.5 newtons. Wonderful. So let me also check. Yeah, seems like the correct answer.
So
Let's
like
do
should
one last
include
question.
force from the electric field also.
Yeah, we should include force from the electric field also. Have you not included? Because that will be really
No,
bad.
sir.
Third force will be in this direction, F3, which will be equal to Q into E. Charge here is 1 microcoulomb, E is 10 in SI unit, Newton per coulomb. And that will do the trick, my friend.
Yes, sir.
Okay, last question. आन बान शान या के प्राण का हो दान आज एक धनुष के बाण पे उतार दो आरंभ है प्रचंड खोल मस्तकों के झुंड आज जंग की घड़ी के तुम गुहार दो आन बान शान या प्राण का हो दान एक धनुष के बाण पे उतार दो आरंभ है प्रचंड मन करे स प्राण ले जो मन करे स प्राण दे वही तो एक सर्वशक्तिमान है मन करे स प्राण दे जो मन करे स प्राण ले वही तो एक ही सर्वशक्तिमान है युद्ध की पुकार ये या के भागवत का सार है कि युद्ध ही तो वीर का प्रमाण है कौरवों की भीड़ हो या पांडवों का नीड़ हो जो लड़ सका है वो ही तो महान है जीत की हवस नहीं किसी पे कोई वश नहीं क्या जिंदगी है ठोकरों पे मार दो मौत अंत है नहीं तो मौत से भी क्यों डरे ये अब जहां जाके आसमान में दहाड़ दो आरंभ है प्रचंड खोल मस्तकों के झुंड आज जंग की घड़ी के तुम गुहार दो आन बान शान या के प्राण का हो दान आज एक धनुष के बाण पे उतार दो आरंभ है प्रचंड आरंभ है प्रचंड आरंभ है प्रचंड प्रचंडम. This is a Pachandam question. I mean, not really, but yeah, we'll have to try. This question is Asura. What was it? I'll tell you the word. I'll tell you. Ati Bhayankara. This question is Ati Bhayankara. Right? Very scary to some people, not you, I'm sure. Do you understand Hindi by any chance?
Yes, sir.
Oh, you do understand. Did you understand the song I sang? What was he saying? That was a very pure Hindi, no? I don't think you got that.
Like only some words like we should not be afraid of death if we are going to be born again.
Arey, wow. You're such a smart guy, man. I like talking to you. Oh, I got Danaveshwara on that one. Danaveshwara. That is the king of devils, Ravana. It's a song dedicated to Ravana. I like it. Do you like it too? Don't answer the question. Off the record. Off the record. अति भयंकरा रावणा जय 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 शेषणा जय 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 रावणा जय 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 सिंहासना ta 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 जय 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 तत्तदा तदा तत्तदा तदा Let's go to some more holy music. Not this one. My love is gone. Bullshit. Let's go to Shankar Mahadevan. He will help us. You know, Ravana was one of the biggest devotees of Shiva. In the Indian mythology, Hindu mythology, to be precise, Ravan was a big devotee of Lord Shiva, according to Hindu mythology. Just think about that. Okay, Sairam, I'll have to take your leave now. There is another student waiting for 5 minutes. You can do this question as homework and continue with more questions.
Yes,
Okay?
sir.
Bye.
Thank you, sir.
You're welcome. Hello.
Good morning, sir.
Good morning, ma'am. How are you?
I'm good.
Okay, let's start.